Hello everyone. So my name is Sevang Patel and today we will discuss about this research paper which is towards all-in-one pre-training via maximizing multimodal mutual information. So let's go forward with abstract. So so this research paper is about let we consider the unified training approach. So normally training deep learning models involves many steps, each focusing on different things like getting feature or fine tuning. But we discuss about the new training approach. It is my M3I pre-training approach, which is makes the different steps of the training in only one step. So it is a new approach and it is improving a lot of performance. So the information sharing formula. So that is a task where you need to understand different kind of information together, like image with text. It is important to share information between them. So the information sharing formula developed with M3I pre-training puts this sharing into a math equation, and it helps train model to use and mix information from different sources, making them work better. And the performance boost, as I told, that it is where it is boosting the performance of the model. Even it is helpful in the billion parameter of model. So next we go to the introduction. So the first topic is a theoretical foundation. So that is about understanding the theory behind big pre-training method boils down to one main goal, making sure the information learned from the input matches up well with the what's the needed for the task at the hand. And this idea helps create a solid foundation for a unified pre-training framework. And this innovation is M3I innovation is about the M3I is a big step forward to how to train model as and it is a new way of training that combine different method into one simple method, and by expanding on the idea of matching input and target information, and it gives the experimentary performance we have done a lot of the test, and this model perform very well on with this method. And the process is a streamlined training process. So the M3 pre-training makes training model much simpler instead of having a lots of complex data set. So now go forward with the related work. So before going to the related work, these are the five different training methods. So this is a supervised, weekly supervised, self-supervised, self-supervised interview means that is the focus on the single view, and interview with focus on the multiple view. So in this interview, it is like the accuracy will be higher, and in this interview, the multiple type of information are combining. So this is our M3I pre-training, which is a single stage. So let us discuss about all this method in the next slide. So the related works like the supervised pre-training. So this method trains a model using a data set where each input has a known label. For example, in image task, each image is labeled with a category. So the model learns to predict this label during the training, typically using methods like classification loss. It's effective but require a lot of label data, which can be expensive. So next one is a self-supervised pre-training. So here the model learns from data itself without needing label. Instead, it predicts certain parts of the data based on other parts. For example, in language tasks, it might guess mask word in a sentence. The third one is a weekly supervised pre-training. So this falls between supervised and a self-supervised method. It uses particularly label or noisy data for training. So the multitask pre-training is about here the model learns from multiple related tasks at once, and each task provide different kind of guidance like classification or regression. So the last one is a multi-stage pre-training. So in this method, the model goes through several stages of training, and each focusing on the objective or data set. For example, it might start by pre-training on a large data set like ImageNet with supervision, then fine-tune on similar specific data set. It is more customized, but it can be complicated and time-consuming sometimes. So this is about the whole six method. So let us discuss about the different method which is used in this data set. First one is the mutual information for generic pre-train. So the objective of pre-training before dividing into specific of pre-training. Let's understand its main goal. Pre-training is all about teaching a computer program to understand what data is better. And another one is a mutual information maximization. So to make sure the program learns this represented well, we use something called mutual information. The approximation of posterior. Now we figure out exactly how much information is shared can be really hard. And the training loss derivation, we set up a problem we need to figure out to train our program. And the instantiation into different pre-training paradigm. Now all this theory can be used in different way. Some method focusing on label data, another on without labels. So the connecting with existing pre-training method. So the existing method come in different flavors like supervised, weakly supervised, so we and self-supervised. Each method has its own strength and uses different kind of data. So the multi-input, multi-target. In some case, we want to more than one kind of input and teach our program more than one thing at a time. So this approach us to capture more about data. And F3 pre-training is fancy name for a method like combine all the data. It uses a multiple input target to teach the program lot of things into once. So the experiment, so the pre-training 1B image backbone. So here we can see that M3 pre-training really predicts well, and the result is really good. So, and the ablation study, we took a deep dive into how pre-training method works. We found that certain things like hiding parts of the image and focusing on specific details really help the network to learn method. And this method is unique because it's forget what it learns and it learns from the different thing on the same time. And the system level comparison with other method is when we compare our method with the other method, so we found that this method is very competitive and uh, this method is performing really well. So the conclusion is the model large scale network relying on combining different stage. So by this method we can optimize the different stage into one stage of training and it gives really good results. So the proposed framework can be applied to even other domains like natural language processing or visual language tasks. And the one limitation we can see that it is only focus on a vision centric pre-training. Thank you very much. This is all about this research paper.